Hello and welcome all of you on the session on Spearman correlation coefficient, a special type of coefficient which is used to indicate the correlation between the two variables in statistics. It is also called as rank order correlation. This particular lecture is under the series of lectures in the module of Stats the way to do it. So let us start with the content. Today we will discuss about the monotonic relationship, why this Spearman correlation coefficient is used. Then we will learn about what is Spearman correlation coefficient, how it is calculated, what is the formula, and then we will have the example case. So let us discuss about the monotonic relationship. As we know, our traditional coefficients of correlation like small r and coefficient of determination are used when there is a linear relationship between the two variables, but the relationship may or may not be always linear. So there is one kind of relationship you can see, it is called as not linear but monotonic. So monotonic relation is one variable increases, the other also increase or instead decreases. So it can be clearly noticed from this monotonic relationship. So monotonic relationship is less restrictive than linear relationship, where we discuss the rate of change of one variable is proportional to the rate of change of another variable. So Spearman rank correlation method provide us the strength and direction of the monotonic relation between the connected variables. This evaluation helps in understanding the relationship and interaction between the variables. So why and when to use the Spearman rank correlation method? So let us know something about the method. So this method was developed by a British psychologist C. E. Spearman. This method is used when the variables cannot be measured meaningfully. So there are many cases when the variables are in qualitative terms or in the status terms. It may be a Likert scale, it may not be a Likert scale, sometimes yes or no, binary answers. So in such case, the Spearman rank coefficient can be used. And ranking may be more meaningful when the measurements of variable are suspected. So it works on the logic of relative rather than absolute. So there are also situations when you are required to quantify the qualities such as fairness, honesty, which cannot be measured in numerical terms. Also, there is sometimes a problem with simple correlation, that the value of simple correlation, that is coefficient of correlation and determination, with extreme values and without extreme values are different. So in such case, Spearman rank correlation provides a better alternative to the simple correlation. Now let us proceed. So we have one Spearman correlation coefficient, which is represented by rho, a Greek letter, or RR, and the formula is 1 minus 6 summation di square upon n in bracket n square minus 1, where di is the difference in rank, n are the number of observation. And here on the right side there are ranges of this coefficient for your easy interpretation. So we will discuss these ranges once the Spearman correlation coefficient is calculated. So there can be three cases. Case number one, data is directly in the form of ranks. Already you have collected the data in the form of ranks only. Case number two, you have collected the data in some quantitative manner and that data needs to be converted into ranks. And case number 3 is a special case when you do the conversion of data into ranks. Sometimes you can see the similar data. So there is tie in the rank, and how to break that tie we will discuss. So let us proceed with case number 1. So case number 1 is the data is already in the form of ranks. So the following table provides the data about rank based on percentage of economically backward class students and their CGPA score. And obviously the state-wise data is given. We are interested in correlation between economically backward class students and their CGPA. If there exists any kind of correlation, so you can so we can see that for EBC student, first rank is Bihar, and for CGPA, first rank is Assam. So we want to know the correlation between these two columns, that is EBC students and their CGPA. Now we already know the formula, 1 minus 6 summation di square upon n square minus 1. Now let us see the solution. So as the ranks are directly given, we need not convert them from data to rank. It is directly rank. Now di, as we know, it is difference in rank. So it is always R1 minus R2. So without worrying about the difference and the negative sign, you just do R1 minus R2. So our R1 is EBC and R2 is CGPA. You can see the ranks. So difference of this rank are to be recorded in this particular column. To start with, what is first difference? 3 minus 4. This will be minus 1. Then 2 minus 6 minus 4. 5 minus 3 plus 2. 6 minus 1 plus 5. 7 minus 2 plus 5. 1 minus 7 minus 6. 4 minus 5 minus 1. Similarly 8 minus 9 minus 1. And 9 minus 8 is 1. And in the last column, as we need the summation of di square, so we will take the square of this column here, like this. So 1, 4 square is 16, similarly, and we get the summation di as 110. Putting this formula, putting this value in the formula, we can calculate our row. So you can see di square is 1110, and sample size, there are 9 states, so sample size is 9. So 9 square minus 1, and our row, that is Spearman correlation coefficient, comes out to be 0.083. Now we will interpret it later as per the ranges. Proceeding to case number 2. Now case number 2 is ranks are to be calculated. So now the following table provides the mark obtained by UPSC aspirants in their prelims and mains examination. And again we will apply the Spearman rank correlation between the two and interpret the results. So in one column there are marks of prelims and mains. In the second prelims, and in the second column we have the marks of mains. So yes, here we are required to convert these marks into ranks. Okay, so for converting the quantitative data into ranks, you have to finalize one criteria, whether you want to rank it from minimum to maximum or from maximum to minimum. So as these are the marks, the logic says first rank will be the person having maximum marks. Okay, so first we will concentrate on this column, first column, and we will convert the first column into rank 1 column. So what is the highest value you can see here is 18. So in this column I will put the rank one by one. So highest is 18, you can see the pointer. So rank 1. Then after 18 there is 17. So rank 2. After 17 there is 16. So rank 3. Similarly rank 4, 5, 6, 7, 8. These are the ranks which I got from prelims column, and I have applied the logic of maximum to minimum. Whatever the logic I apply, that will same for the rank 2, that is the marks of mains. So highest marks in the mains column you can see is 12. So you can see rank 1 here. Then after 12 there is 10. So rank 2 here. After 10 there is 9. So rank 3, and similarly 4, 5, 6, 7, 8. Now we have got our ranks for both the columns. So now technically we will forget about this quantitative data, because for calculation of Spearman we need difference in rank and sample size. Sample size here is 8. So again similarly, without worrying about the sign of the difference, we will do 5 minus 6 is minus 1, 4 minus 1, 3, 2 minus 4 minus 2, 6 minus 2, 4, 3 minus 8 minus 5, 7 minus 5 gives me 2, 1 minus 3 gives me minus 2, 8 minus 7 gives me 1. Again I will need a column di square, so I will take square of this column here. And finally square column summation. The summation is coming out to be 64. Now putting this value into this formula, sample size is 8. The Spearman correlation is coming out to be 0.238. So this was our case number 2. Proceeding to case number 3, ranks are similar. Now this is one type of typical problem where two judges are judging a common participants, but their marks are different. So to check the consistency of the judges, we can also use Spearman rank correlation. So the scores of two judges may be different, but they should be correlated. So to check that, this is a typical problem which I have selected for the viewers, so that you also get a flavor of application of this Spearman coefficient. So you can see the question. The following data provides marks obtained by a participant in a dance competition, and following factors, these are the factors: steps, moves, energy, props, consistency, coordination, expression, and flexibility. So these parameters were judged by two simultaneous judges, and their scores you can see are different. And these are the scores for a single participant. So participant is one, getting judged by two different judges, and we are checking the consistency by Spearman rank correlation. So as we know, again the data is quantitative. I will be needing it to convert it to ranks. Now we have scores of two judges on two columns, and as these are the scores, we have to convert it into rank. Again, these are the scores, so we will apply the logic of maximum to minimum while ranking it. And we can see that if we go from maximum to minimum, we first rank will be on this 20. So highest marks are 20. So first rank we can give. But whenever I see after 20 there is 19, but 19 are at two places. So there is a tie. Okay. So for the rank 2 there is a tie. Now how to break this tie? So some tie breaking rules are there. And what are those? Number one, find out the ranks under tie. So where is the controversy? Now the controversy is 19 is at two places. Okay, so I can't give second rank and third rank. So the ranks under tie are second and third. What to do when there are ranks under tie? So take a mean of the rank and assign to both. So what is the mean of second and third? It is 2.5. So I have to take a mean of second and third rank, that is 2.5, to both the entries, that is rank number 1 is 20, and as there are two 19s, I will assign the rank 2.5 to both. Now we have assigned the mean rank to both. Now what to do? So the ranks under tie, that is 2 and 3, will be omitted from the scenario. There will be no rank 2 and 3 because we have provided the mean rank to two values. Okay, so now 2 and 3 are omitted. So next rank will be 4. So what after 19? It is 18. So 18 will be assigned with rank 4. Then 17. 17 will be assigned with rank 5. Then 16. 16 will be assigned with rank 6. Then 14. 14 will be assigned with rank 7. And last 11 will be assigned with rank 8. Similarly, when we see the marks of judge 2, we will start with the highest. So highest is 19. So yes, 19 can be assigned with rank 1. After 19 there is 18 assigned with rank 2. After 18 there is 17, but 17 are at two places. So now the tie is between rank 3 and 4. So what can we do? Take the mean of the rank, that is 3.5, and we will assign to both the 17s, that is 3.5. Also, rank 3 and 4 will be omitted, so next rank will be directly 5. So what after 17? It is 16, so 16 will be assigned with rank 5. After 16 there is 15, this, so it will be assigned with rank 6. Then after 15 there is 14, but oh, there are two 14s. So for rank 7 and 8, again there is a controversy, there is a tie. So again we take a mean of 7 and 8, that is 7.5, and we assign to both the 14s. So the blue color values you can see in the table are because of tie, and we have to take the ranks like this. Once you break the tie like this, rest of the question is same. You have to find the difference in rank. So 6 minus 6 0, 1 minus 2 minus 1, 5 minus 7.5, 8 minus 7.5, 2.5 minus 3.5, 4 minus 1, 7 minus 3.5, 2.5 minus 5. And finally, as the previous cases, we take square of the difference in rank. And finally, summation. So summation is 36. So putting this value in the answer, in the formula, we get coefficient, Spearman coefficient as 0.571. Okay. Now you can see the interpretation which we discussed early, but not in detail. So when the value of Spearman is less than zero point 0.3, it is very less correlation. If it is between zero point 0.3 to zero point 0.5, it is low correlation. Zero point 0.5 to 7, it is medium. 7 to 9 is high correlation, and zero point 0.9 and above is very high correlation. So for all the three cases, our values are this. So first value indicate very less correlation. Second value 0.238 indicates very less correlation. And third 0.571 indicates medium correlation. So in this way, when there is a monotonic relationship between the variables, not necessarily be linear always, and when the data is qualitative, not measurable, so we can use the Spearman rank coefficient, and we can use these results for getting some kind of insights for our business decision making. So thank you. I hope you all have liked the lecture. You can post the queries if any to the comment box. If you like the video, like, comment, share and subscribe the channel.